In this video, I'd like to spend some time just talking about pressure. Now, I know we're all under a lot of pressure right now for many different reasons. And while the units of pressure that I'm referring to are a bit different, in some ways they're the same. So let's talk about pressure to a certain extent here. Well, if you've ever been to the circus or Key West, Florida, I've been to Key West once, I distinctly remember the guy laying down on the bed of nails. And while I like all of you a lot, I don't like you enough to lay on a bed of nails and take my life in my own hands. But I think you might argue that the old bed of nails analogy does show us really what pressure is. If I put my hand over top of one nail and jam it really hard, that's probably going to hurt. And the reason why it hurts is because the force is distributed over just the head of the nail. Now, the reality is, when you see the bed of nails experiment, when the person lays on the bed of nails, it's all sharp and pointy here. Mine's blunt. This is just the head of a nail. But I think you'd agree that this is quite sharp in terms of the amount of pressure that's exerted over, or force over that small area. On the other hand, this small bed of nails here kind of equally distributes the area over a wider range, and when I put my hand down on top of those nails, it doesn't hurt. And that's because we've got the same force pushing down, but the area is larger. So that's the easiest way to look at pressure. Pressure is really force per unit area. Now, what has that got to do with gases? Well, most of you, if you've been interested in weather, like I am, maybe you look at the barometric pressure. And in some cases, maybe you get a headache when there's a real high pressure coming through or a low pressure coming through. A lot of people tend to believe that they have built-in barometers in their own heads. I don't tend to get pressure headaches, but I know a lot of people that do. Well, this is a barometer, and it's pretty old. And you can see the units. Okay, the inside units are actually inches of mercury. That's a US system. The outer band involves centimeters of mercury. So today you can see it's actually a beautiful day. The pressure is about 77 centimeters of mercury, or over 30 inches of mercury. So this is a barometer. This is called an Aneroid Barometer because it does not use mercury. The original barometers that we used did. So let's talk about pressure. Well, in physics, some of you may have learned that pressure is simply force per unit area. Hence my bed of nails versus a single nail analogy. There's our triangle. Pressure is force over area. The unit for force is a Newton, and the unit for area is square meters. So 1 Pascal of pressure, which is a metric unit, is equal to 1 Newton per meter squared. Well, a man by the name of Taurus, and that certainly does sound Italian because he was, way back in the early 1700s, built the first barometer. Now, I'm so old I remember in a chemistry lab building my own barometer with pure mercury. Not a good move because pure mercury is a neurotoxin, and when it gets into the plumbing, it stays there. It's really bad as a bioaccumulator, so we don't use mercury any longer. So you'll have to deal with my picture. This was Torricelli's barometer. Very simple design. At sea level, he actually did his studies in Sicily, Italy, which is right at sea level. And he found that when he put quite a volume of mercury in a reservoir and inserted a long glass tube, which he had evacuated using a vacuum pump, that the pressure due to the atmosphere pushing down caused that mercury to rise up the tube exactly 760 millimeters. That's 76 centimeters, which is just a little more than 3/4 of a meter. So, you know, quite a large amount in terms of movement of that mercury. That is what Ellie called standard pressure. And standard pressure becomes a really important thing in the gas law unit because pressure changes quite readily for gases. So we have many units for standard pressure. One unit we would use is 760 millimeters of mercury. That is the same as 760 torrs, named after Ellie himself. But we also use atmospheres. Those of you interested in Jacques Cousteau or scuba diving, maybe you've got your own scuba diving ticket through PADI or NAUI, you might be using atmospheres in that case. So 1 atmosphere is the same thing as standard pressure, or 760 millimeters of mercury. The unit that we tend to use the most in the SI unit, which is a metric unit, is kilopascals, and that is 101.3 kilopascals. To be honest, it's 101.325, but we're going to use 101.3 rounded off. That's good enough for our purposes. In America, they might refer to standard pressure as 14.7 pounds per square inch. Again, our tech classes use this pressure unit quite a bit if you are inflating the tires in your car. And you should always look at the number on the wall of the tire before you keep pumping air into it so you don't overinflate it. Now, we have to be able to convert our units. This is part of the fun and games that we have to go through in the world of atmospheric chemistry. So if we have 2.24 atmospheres, which is quite a lot, it's more than double atmospheric pressure, we can convert that to kilopascals very easily because we know that 1 atmosphere is 101.3 kilopascals. So if we multiply 2.24 atmospheres by 101.3 kilopascals per atmosphere, our units cancel, right? Just like we always did in the past, and we end up getting 227 kPa or kilopascals. If we go the opposite direction, sure, we can convert kilopascals into atmospheres, kind of doing the opposite mathematics. So 324 kPa, which we know is more than 3 atmospheres, if you think about it. 1 atmosphere would be 101.3 kPa. If we go through this math, we multiply the 324 kPa times 1 atmosphere per 101.3 kilopascals. Again, cancel out your units, and lo and behold, we get 3.2 atmospheres of pressure. The final conversion I'd like to go through with you involves converting millimeters of mercury into kilopascals. It's really no different. All we have to do is use a conversion factor that involves kPa in millimeters of mercury. So 875 millimeters of mercury, which is a little bit more than standard pressure, you may recall is 760. If we take that number 875 and we multiply it by 101.3 kilopascals divided by 760 millimeters of mercury, we get 117 kilopascals of pressure. So, in just over 9 minutes, that is a quick look at pressure. Remember, pressure is force per unit area. We use a barometer to measure air pressure, and we have many units for pressure in chemistry, but the one we use the most is definitely the kilopascal.